Hey there, and welcome. Today, we are going to pull back the curtain on something that, believe it or not, secretly runs our modern world. It's kind of like an invisible engine, a hidden language behind the most amazing technology we use every single day. So, let's see what this engine is actually powering.
You ever watch a blockbuster movie and you're just floored by the special effects? And you wonder, how in the world do they make a digital dragon look so real?
Or what about this? How does a service like Spotify or Netflix seem to just get you? Recommending that perfect song or movie you didn't even know you were looking for?
And then there's the really cutting-edge stuff. How does the self-driving car see the world around it and plan a safe route through a totally chaotic city street?
Okay, so CGI, music recommendations, self-driving cars, they all seem completely unrelated, right? Well, what if I told you there's one single, fundamental concept that connects them all? Like a master key that unlocks all this incredible technology.
The answer, well, it goes deeper than just programming or lines of code. It's actually a mathematical framework that gives structure to all kinds of information. It is truly the code behind, well, everything.
And that answer is vector spaces. Now, I know that might sound a little intimidating, but just stick with me here, because understanding this one idea is going to give you a whole new lens to see the world through.
So, forget about complex equations for a second. At its heart, a vector space is basically a super-organized filing system for data. But here's the trick. Every piece of information comes with both a magnitude, that's its size or importance, and a direction. Just think of it like giving someone directions. You'd say, walk 3 blocks north. 3 blocks is the magnitude, and north is the direction. By organizing data this way, we can do some really powerful stuff with everything from the color of a pixel to financial risk.
And hey, it's not just me saying this. As the source material puts it, vector spaces are everywhere. They're not just stuck in some math textbook, they are in the movies we watch, the music we listen to, and the cars driving down our streets. So, let's see them in action. All right, first up, let's start with the visual world. The screens we stare at every single day. This is where vector spaces basically become artists, painting our entire digital reality with nothing but numbers.
Just look at your screen right now. It's made of millions of tiny little dots called pixels, and each and every one of those pixels can be described as a vector. It's just a simple list of 3 numbers telling you how much red, green, and blue light to show. Your entire screen is really just a massive collection of these little color vectors.
And this idea just blows up when you get to 3D animation. A character in a movie, it's first built from a bunch of points, all defined by vectors. Then, animators use the rules of vector math, which is a field called linear algebra, to apply transformations, rotating, scaling, and moving that character around. It's a perfect example of how some pretty abstract math brings our favorite animated heroes to life.
But vector spaces don't just create images, they also make them manageable. When you take a photo and the original file is huge? Well, when it's saved as a JPEG, techniques based on vector spaces are used to figure out what information isn't absolutely essential, and then toss it, which shrinks the file size down like crazy, and you barely even notice a difference.
So here's the really crucial point. Without vector spaces, sending a photo, streaming a movie, or even just loading a web page would be incredibly slow, if it was even possible at all. They are the absolute bedrock of our digital communication.
Okay, so vector spaces help create our digital world, but they're also how we make sense of it. Now we're going to shift from looking at pixels to finding patterns, where these mathematical structures act like a compass, helping us find meaning in this huge, chaotic ocean of data.
So get this, here's a mind-bending thought. To a service like Netflix, you are a vector. Your tastes get turned into a list of numbers, a single point in this massive, multidimensional space. Now, why is that so powerful? Because the system can then mathematically measure the distance between your personal taste vector and the vector for every single movie out there. If the distance is short, it's a great match. It's an unbelievably efficient way to find things you'll like among millions of options.
And the exact same logic applies to a totally different field, finance. An investment portfolio? It's really just a vector, where each number represents how much you've invested in a certain asset. Analysts use vector operations to model risk and try to maximize returns in a super complex market.
And this is why vector spaces are at the very heart of modern data science and AI. They give us this incredible way to translate complex, messy human behavior and financial data into a structured format that a computer can actually analyze to find patterns we'd never be able to see on our own.
Okay,
Now let's take this concept out of the computer and into the physical world. Because vector spaces aren't just for digital information. They are absolutely essential tools for the engineers and roboticists who are building the world all around us.
Think about a bridge for a second. The wind pushing against it, the weight of all the cars crossing it, these are all forces, and they all have both a strength and a direction. So engineers model these forces as vectors. By adding them all up and analyzing them, they can make sure the bridge is designed to be totally safe and stable.
And here we are, full circle, back to one of our first questions. A self-driving car is constantly using vectors to make sense of its world. Its position is a vector, its speed is a vector, and every single obstacle it sees is mapped out using, you guessed it, vectors. It then calculates a safe path by navigating through this incredibly complex vector space, all in real time.
So whether it's a robot arm in a factory or a rover exploring Mars, the ability to navigate the physical world all comes down to this fundamental mathematical language. It's the essential tool that lets machines perceive, plan, and act.
So we've seen how vector spaces paint our screens, recommend our music, manage our money, and build our world. So what's the big takeaway here? It's that we've found the master key.
The truly incredible thing is that one single concept, this invisible engine, is what powers all of these totally different things. From the art of CGI to the hard science of engineering, vector spaces give us a common language to describe and work with really complex systems. It's the ultimate tool for turning abstract data into real-world solutions.
So, the next time you watch a movie, listen to a song Spotify picked for you, or see a self-driving car cruise by, you'll know about the elegant, powerful structure working silently behind the scenes. Now that you can see the invisible engine, what will you understand next?